Today I will be responding to the following objective. I can determine my delta V, or my potential difference, along a path between 2 points in a region with a non-constant electrical field. In order to do this problem today, I have drawn out a chart of what the problem really is at its core. So in this problem, I have 3 electrical fields, E field 1, E field 2, and E field 3. And they all are exerting a different electrical field on our 2 points, point A and point B. And so my question is, given the following parameters, what is going to be my potential difference between these 2 points? And so there are a couple of different things I can exploit about potential difference. The first thing is that I have the following additive property, that my delta V is equal to delta V1 plus delta V2 plus delta V3. And it so happens that delta V is a path-independent quantity, which means that I can go from path A to path C to path D, from path D to path B, to give me an overall quantity of delta V from path A to path B. And so I've assigned a couple of distances between the two so that we can calculate this quantity. So the first thing I'm going to do is go to my equation. So the equation for my delta V is the negative electrical field dot product with the change in distance. So I have my electrical field dot producted with the change in my distance, and then I get a negative 3 volts, And then for my second component, I do the same thing. I have the electrical field, and I have that dot producted with my another distance, which is going to be my E2 over here, and that gives me negative 40 volts. And then my final component is my number 3 section. So I have my E field here, dot producted with my distance, so my change in my y direction, because that is the only direction in which I am changing, and I'm getting a negative 12 volts for that. And so my final step here is to summate, or to do a summation function on all of these, and I get negative 3 volts, negative 3 volts plus negative 40 volts plus negative 12 volts, and that gives me a grand total of negative 55 volts of my potential difference in this constant electrical field. And I hope you enjoyed that.